Hi, this is Jason Baker, and I'm back to talk about some of the more advanced capabilities and features that you'll find in the Linux file system and in the Bash shell interpreter. One of the most common features that you'll use when working with the Linux interpreter is something called file globbing. And I talked about globbing a bit in the shell scripting section. You can use file globbing at the Linux command line as well. For example, if you're in a directory and you want to list all of the JPEG files in the directory, you can say ls star.jpg, and that will give you a list of every file in that current directory which matches this these special characters. So the asterisk character will match any set of characters .jpg. If I want to just list files that start with the maybe start with the F character or FO, I can say FO question mark .jpg. That will just match one file in this case. In this match, any value can be substituted for that question mark, but only one that represents only one possible character value. So we can use file globbing when within our shell scripts, and we can use file globbing at the command line if we're referencing files. This can be really helpful if, for example, we do a directory listing and we see like some configuration files. If I want to remove all of the configuration files in this directory, I can say remove star.conf, and it will remove the backup.conf file and the nginx.conf file. One of the most important concepts to understand when working with the Linux shell is that you can redirect inputs and outputs in the shell, within that shell environment. And you can do this from the command line. You can also do it from within a shell script. By default, when you're inputting information into a program or into the shell interpreter, you're inputting data from what's called the standard input. And by default, that's your keyboard. Like when I'm running commands here, I'm typing these commands on my keyboard and I'm inputting them in. So the standard input is my keyboard. When I'm outputting, when the shell is running a command and that command is outputting some data, the command is going to output that information to the standard output, which by default is my display. So I ran this ls command. The ls command outputted the names of the files in my current working directory, and it output those names to my display. Outputted it to my terminal application, and it shows up on my monitor. That's the standard output. There are times when we want to sort of rewire the standard input and standard output on our system. So we can redirect these input-output pathways that are in use by our Linux programs. And you'll see in a minute why you might want to do that and why that's really helpful. If I want to redirect the output of an application, I can redirect the output of an application by using the right angle bracket character. Here you can see I'm doing a directory listing of my home directory, and instead of outputting that data to my display, to my monitor, I'm going to output that data to a text file. So I can capture that output and put it in a text file. Here's my directory listing. If I were to do a directory listing within this directory and say, I'll put that directory listing to a file called listing.txt. And if I look at the contents of that file, you see that the contents of that file is my directory listing. So that ls command, instead of outputting the directory listing to my screen, it's outputting that data and saving it into a text file, which is really, really useful. Because sometimes I want to be able to capture the output of something and I want to store it permanently somewhere. I don't want to just look at it, I want to write it to a file for further analysis. Now, if I wanted to append the data to an existing file, I wouldn't want to use this single right angle bracket character, because the single right angle bracket character will create a new file or it will overwrite the contents of an existing file. If I want to append to the contents of an existing file, then I need to use the double right angle brackets characters. I need to use 2 of them. Let me do a directory listing again, and I'm going to use the double right angle brackets. Now if I cat listing.txt, you'll see all my files are now listed twice because I've appended another directory listing to that existing file. So that's how you can easily redirect the output of a command. You can also redirect the input for a command as well. You might be thinking, well, why would I want to redirect the input for a command? Well, typically when you're running commands, you're running them from a keyboard. But what if you want the input of a command to be some data that's in like a text file? You could use that as the input for a command. Here's a very simple example. We're going to run a program called word count, and we're going to ask it to count the number of lines in a file. Before I do that, let's make sure we have a file that's got some content. We've got our listing.txt file, right? That's got some content in it. Let's use the word count program to count the number of lines in our listing.txt file. So we're going to use the listing.txt file as the command input. That's where it's going to take the data from to perform a word count. I hit enter and it comes back with 12. There are 12 lines of text in this listing.txt file. I've redirected the listing.txt file contents and I've turned those into an input for the word count command. So you've seen now 2 different ways to redirect, to use IO redirection. We can redirect the output of a command, and we can redirect the standard input for a command. There's one other way that we can redirect IO in our commands. And this is an incredibly powerful feature within Linux and within Unix as well. It's something that you see used all the time in most every shell script and many commands that you'll run on the command line. You'll take advantage of this command pipeline feature. What the command pipe allows you to do is it allows you to take the output from one command and use that output as the input for another command. And the way you can pipe command to pipe data between commands is by using the vertical bar character. Let's look at a simple example here. In this case, we want to list the directories, list the contents of a directory. We can list the contents of a directory and take the output of that directory listing, and we can use the output of this directory listing as the input for the sort command. Maybe let's see if we can. This isn't a good example here because this directory listing is uh, is already sorted. But let's try it anyway. So we're gonna list the contents of our current directory, and we'll run those through the sort command. And that will give us a list of files, and those files are sorted alphabetically. Let's look at the sort command real quick and see what other options it gives us. So we can sort it in reverse. So let's try that. So if I list the current working directory, the files in the current working directory, it's going to output those files, and I want to pipe that output into the sort command. I'm going to pass the sort command the -r attribute, which means sort, perform a sort in reverse order. So now you can see that it's providing me a list of the files in the directory, but now those files are sorted in reverse alphabetical order. A really, really powerful capability. I can't state this strongly enough. The the command piping is incredibly useful when you are working on and adding commands into shell scripts or working with commands from the command line, because it allows you to take relatively simple commands and use them as building blocks to build up a much more sophisticated command statement. Now, the Linux operating system and the Linux kernel allows you to execute and run programs and run services, just like every other operating system. And at any given point in time, you'll find that there's dozens of different services and software applications running on the Linux system. Some of these services are transient and they're very short-lived services. Like every one of these commands that we're running starts up a program. So when I run ls, that's starting up the ls program. But that ls program just runs for a very short period of time. Other programs that I run are long-running programs. And these are things that we call services or daemons. These might be things like web servers or database servers or proxy servers. And these are services that will run in the background. If I want to look and see and look at all the current running processes on my system, I can use the process command. So I can do like a ps-ax, and this will give me a listing of all the different processes that are running on the Linux server. The key thing to note is that every process has its own ID, a PID, a process ID. So every single process can be referenced using a process ID. So PSA-AX is one way to look at processes. Another handy way to look at processes is by running the top command. When you run the top command, this is like kind of like running the performance monitor on a Windows system. It will give you some information about CPU statistics, the amount of memory that you're consuming, your current load average on the system. It'll show you the processes that are running on the system and how much CPU and how much memory each one of those processes is consuming. If I wanted to stop a process on the system, if I wanted to forcibly stop a process on the system, I could use the kill command, and I could try to, I'd kill, and then I'd pick a process on the system. I don't want to actually kill any of these processes, but I would type in a process number, and that would allow me to forcibly kill a process that's running on the system. Generally, that's not the easiest way. I'll show you an easier way to stop services that are running on the system. You would only want to kill a process if for some reason that process was not stopping normally. I mentioned that some of the processes on your system represent long-running applications. We call these services. And Linux provides you with a way to manage the state of services that are running on your system. Um, I don't know that we have a couple services like this network time protocol daemon service. You see the cron D service. This is a scheduler, a process scheduler that's running on our system. We're not this basic system does not have a web server or anything installed on it yet. And I'll show you how to do that here in a bit. If we wanted to start a service or stop a service on a system, we could use the service command. And generally, if we want to start and stop services on a system, we need to have root privileges, meaning that we need to precede our commands with the sudo command because we need escalated privileges on the system. So we're going to say sudo service, we'll say cron d stop. And the system is going to stop the cron d service. If I wanted to start that service back up, I'd just say sudo service cron d start. And I could say sudo service cron d status, and it'll give me some status information and tell me that that service is running on the system. There are some services that we want to start when the system initially boots up. If we want a service to start when the system boots up, then we use the check config command to tell the system to configure a service to start automatically when the system is booting up. So for example, if we wanted the web service to start when the system starts up, we say sudo check config httpd on. And now that service will start up when the system boots up. Okay, the last thing that we'll cover in this part of the lecture is package management. Now, every Linux distribution, as I mentioned earlier, comes prepackaged with a whole suite of different applications. But oftentimes, what we need to do is we need to install our own applications on the server. We need to install a web server, or maybe we need to install a database server. And so we want to be able to customize the server to suit our particular needs. Installing software on a Linux system, if you were to try to do it manually, it would be really tricky to do because oftentimes software applications are dependent on different libraries, shared libraries that may or may not be installed on the system. So what you have in effect are you have these dependencies that exist between software applications that you want to install and different shared libraries on the system. Well, to make installing software really easy on the Linux system, the Linux distribution includes a package manager. And the package manager allows you to track which software applications are installed on the system, which dependencies are installed in the system, and allows you to cleanly add and remove software packages. And this package manager is one area where you'll see differences between the various Linux distributions. For example, the Amazon Linux and the Red Hat Linux distributions use a package manager called Yum, whereas something like Ubuntu uses an apt-get package manager. So there are two different flavors, two different types of package managers that you'll see in use. And there's actually there's more than that, but those are the two most common ones. Okay, if I want to install software packages on my Amazon Linux system, I'll use the Yum package manager. And so one of the first things I'll typically do when I'm working with a new Amazon Linux server is that I want to update all of the currently installed software on the system. It's kind of like doing a Windows update. If I want to do a system update, I'll do a sudo yum update. Let me clear the screen first before I do this. I'll do a sudo yum update -y. And yum will scan my system, figure out all the packages that are needed, and then it will go out and automatically download and install any necessary packages. Again, this is kind of like running a Windows update on my server. Okay, it's installed an updated package. If I want to install a new application, let's say I want to install the Apache web server, I'm going to do sudo yum install and then the name of the package, in which case the Apache web server is called HTTPD. So sudo yum install HTTPD. It's gonna say, okay, here's the package I need to install plus 4 dependent packages. Is this okay to install? Yep, go ahead. So went ahead and installed all the software needed for my Apache web server. If I wanted to remove that web server software that I just installed, by the way, just because I installed the web server, the Apache web server software, does not mean that software is actually running yet. I didn't actually start the Apache web service. And the reason I didn't want to start it is because I haven't actually configured it yet. So I have to configure the service, configure the web server properly. I'd want to install my web server files, my website files, and then I'd want to start the web server. If I want to remove that web server package, then I do a sudo yum remove HTTPD. And yum will cleanly remove those web server software packages. So yum is a really important application that we can use to add and remove software packages from our Amazon Linux system. Okay, one last thing. There's a command I can use if I want to shut down my Linux system. You can shut down the Linux system by going to the Amazon website console. You'll learn how to do that in this course. But if I wanted to shut down my system from the command line, I can just do the sudo shutdown command. If I wanted the system to reboot right after or restart right after it was shut down, then I can add the -r now argument. So this says shut down the system right now and then reboot to restart after it's been shut down. Okay, that's it for this segment of the lecture, and I hope you enjoyed it.